Hey chemistry students, this is Mrs. Miller, and today what we're going to do is we're going to continue on talking about metrology, so metrics, and the study of measurement. And what we're going to do today is we're going to build off what we learned the other day, and now we're going to move into dimensional analysis. So in the previous video, what you guys learned was something called the stair method. So the stair method is great when we are going from the units of metrics that are the same. So like we're going from kilograms down to grams, or we're going from centimeters up to hectometers, or something like that. However, oftentimes we have to use a different method called dimensional analysis because we are using one set of units to get to another set of units. So what dimensional analysis allows us to do, it's a process used to convert from one set of units to another using appropriate conversion factors. And oftentimes the issue with these are we are going from or between, oops, that's the wrong one. We are going between the English units and metric units. So those guys don't really play well together. So for example, what we have here is how many miles, which miles would be English, and then in the metrics, we have kilometers. So we can't just easily get to that. What we have to do is we have to be able to understand how those conversion factors are going to work together. So what we're going to do in this video is learn how to go between the English and the metrics. So to help you guys with that, if you actually go into the Google slide presentation, all three of these are linked for you. The first one is dimensional analysis explained in words only, with a video with voiceover explanation, or the video without the voice. You can, if you're in the actual Google slides, you can click on this picture and it'll go through it. Otherwise, it is a great video, so I did include a QR code in case you guys want to view that. However, I'm going to be going through the entire process with you with 3 different examples. When we talk about dimensional analysis, we are going to start off by doing the exact same steps over and over and over. So it's important that you guys understand dimensional analysis because as we get into second semester and we start doing stoichiometry, you're going to be using dimensional analysis all the time. So we have our 5 steps. Step 1, we're going to start by writing down what we know or what we are given. What we're given in the problem. And notice it says both number and unit. So that's going to be really important for us. So for example, this is step 1. Where we have 140, which is the number, and then centimeters, which is the unit. Next, what we're going to do is we're going to put it over 1 to make it a fraction. So I'm going to switch colors. I'm going to put it over 1 to make it a fraction, like we did right there. Step 3 then is where we're going to figure out our conversion factors. So what conversion factors are they are factors that are going to allow us to go from one unit to another, but if we look at them, they simplify to 1. So for example, some great conversion factors that we see here are 1 inch and 2.54 centimeters, and then 1 foot is 12 inches. So we know that for every foot it's 12 inches, and most of you will probably know that 1 inch is 2.54 centimeters, but those are what we call the conversion factors. So they actually simplify down to being 1. And the way that we put these conversion factors together is, if you notice, centimeters is on top. We want to get rid of centimeters, so what we're going to do is if it appears on the top and it appears on the bottom, they are going to cancel out. So centimeters on the top, centimeters at the bottom, so we put the appropriate unit on the bottom, so 2.54 centimeters, 1 inch goes on top. Now I want to get rid of inch so I can get to foot, so I'm going to put inch on the top because it's already there. So the next inch goes on the bottom, so it cancels out. and we're left with feet, which in this case is what we want our answers to be. So that also went through step 4, cancel like units. And then our last step here is to multiply everything on the top and divide by anything on the bottom. So in this case, in my calculator, what I would do is I would say 140. You could say times 1 because as you can see that's on the top, but I'm not going to do that. Divided by anything on the bottom. So 2.54 is on the bottom, as well as 12 is on the bottom. So when I take 140 divided by parenthesis, the parenthesis is really important so that your calculator does order of operations. 2.54 times 12, what you end up with is 4.59. We can only have 2 sig figs though, so we end up with 4.6 feet. So we're going to practice a few of those on our own. So here's the first problem that we're going to start with. So we're going to say that it's something mild. We have a roll of copper wire and it's 15 feet long. What we want to know is what is the length of the wire in meters. So again, we're going something in the English units to something in the metric units. So that's why we have to use dimensional analysis. The first thing that you guys have to figure out is how many feet are in 1 meter. And this conversion factor is coming right from your red reference sheet. And that is 3.28 feet is equal to 1 meter. So I'm going to go ahead and in this yellow box, I'm going to go and write down exactly what you guys should be writing down. So when you go through dimensional analysis, the first thing that you do is write down what you know. So that's whatever numerical value you're given in the equation. So in this case, I have 15 feet. So that's step 1. Step 2 then is to put that over 1 to make it a fraction. And then we create something called a t-table. So we call it a t-table because it makes a t. And then we're able to go ahead and use conversion factors to cancel out feet and eventually get to meters. So once I have these, I want to go and I want to cancel out feet. So I know my conversion factor for my red reference sheet is for every 3.28 feet, that's equal to 1 meter. Well, feet appears on the top right now, so it also needs to appear on the bottom. And that's so I can cancel it. So 3.28 is the value that goes with it, and then the other value goes on top. So I put 1 meter on top. Next, what I can do is I can go ahead and I can cancel the like units. So feet appears on the bottom. It also appears on the top. So now what I'm left with is meters. Is that what I want my answer in? What is the length of the wire in meters? Sure is. So that's all I had to do. Now what I'm going to do in my calculator is I'm going to take 15 divided by 3.28. I plug that in my calculator and I end up with 4.57317 meters. And then what I'm going to do is I just need to go back to sig figs. I only have 2 sig figs, so I can have an answer of 4.6 meters as my answer. So as I'm looking at it, down here is kind of a cleaner version. But what you can see is every time I write out a numerical value, like 15 or 3.28 or 1, it always has a unit with it. If something is on top, it also needs to appear on the bottom to go ahead and cancel. And anything that you have on the top gets divided by anything that you have on the bottom. And then always use your sig fig rules. Our next question is going to be how many kilograms are in 7 pounds? Well, the first thing that you guys have to do is you need to find on your red reference sheet how many pounds convert into kilograms, or what is that conversion. So go ahead, pause the video, and figure out what your conversion factor is. So hopefully you guys were able to find that 2.2 pounds is equal to 1 kilogram. So what I'm going to do is in the blue box this time, I'm going to go ahead and start writing down what you guys should have. If you want to try practicing this on your own, go ahead and pause me and give this a try. So what I'm going to do is I'm going to start by using step 1, writing down what I know, which is 7 pounds. The next step, step 2, is I'm going to put this over 1 to make it a fraction, and then I'm going to extend my t-table out. I know that my first conversion factor that I need to use is 2.2 pounds is equal to 1 kilogram, but what goes on the bottom? Well, again, I want to look at what's on top right now. Remember, we want to cancel that. So I'm going to put that same unit on the bottom. So I'm going to put 2.2 pounds on the bottom, 1 kilogram on top. I know that because pounds occurs on the top and the bottom, I'm able to cancel those out. Right now my answer is then in kilograms, and it says how many kilograms are in 7 pounds, so I know I'm at the end. So then what I want to do is I want to plug this into my calculator. So I'm going to take 7 divided by 2.2, and when I do that, I end up with 3.18, and again, I need a unit on it, kilograms. But when I look at my sig figs, I only have 1 sig fig. So when I go and I give you an answer, it's going to be 3 kilograms. So again, what I want you to notice here is every time we write out a numerical value, we go ahead and we also put a unit on it. If you don't get in the habit of putting in units now, you are really going to be struggling in second semester. So every time you write a value, write a unit with it. And for our last one that we're going to try together, this one is going to take a little bit longer. It's a multi-step question. So it says, how many seconds are in 22 days? So I'm going to start the same way that I always do, and I'm going to go by writing down what I know. I know that I'm starting with 22 days. I'm going to make a t-table and put this over 1 to make it a fraction. So I started by writing down what I knew, then I made it 1 into a fraction. Now I need to figure out my conversion factors. Can I go directly from days to seconds? I could, but I'd have to do a lot of math. So I'm lazy. I'm not going to do that. So when I start thinking, what's smaller than a day? Well, in a day, I can figure out how many hours are in there, right? So my first conversion factor is if I have 1 day, how many hours is that? Well, hopefully you know that's 24 hours. So days is appearing on the top. Where does it also have to appear to cancel? Right, that's on the bottom. So I'm going to go 1 day on the bottom, 24 hours on top. So now days cancel. If I were to have an answer right now, it would be in hours. But is that what I want it to be in? No, because I want it to be in seconds. So what's smaller than an hour? Well, if I look at an hour, I can bring that down to minutes, right? So 1 hour is equal to 60 minutes. So again, hours is appearing on the top. Where does it have to appear to cancel? On the bottom. So I'm going to do 1 hour, 60 minutes. Still not to the end yet because I want my answer to be in seconds and I'm in minutes. So I'm close. I'm just not quite there. So what's smaller than a minute? Of course, that's a second. So if I have 1 minute, how many seconds does that equal? Well, of course, that's 60. So if minutes appear on the top, where does it also have to occur? That's on the bottom. So 1 minute goes on the bottom. 60 seconds go on the top. And when I look, hours appear on the top and the bottom, so they cancel. Minutes appear on the top and the bottom, so they cancel. Now when I look, the only unit that hasn't been canceled is seconds, and is that what I want my answer to be in? Heck yes it is. So this is a tough question because it's a 3-step, but you guys can do it. So then in my calculator, what I would do is everything on the top, 22 times 24 times 60 times 60, and then everything on the bottom is 1, so I don't even have to divide anything. So I get a really large number. So that's the answer that I get, but again, I can only have 2 sig figs, so when I break this down to 2 sig figs, my answer ends up being, that's what we get. So when we look at the cleaned up version, you guys can see the same thing. We started with the value that we were given, put it over 1, and then just start going through your conversion factors until you're left with a unit that you're looking for. Everything else should cancel. So be sure that you are writing units with everything. If you guys have any questions, let us know. Otherwise, have a great day.